Okay, so we are going to be solving inequalities today, which is just like solving equations, except for we just won't have an equal sign. So here would be an example of our first inequality. So the only thing that's different is we have, oops, hold on a second, I want the laser. We have an inequality symbol, so this is greater than or equal to, but we're going to treat this just like it's an equation, and so we solve it exactly the same way. So we're going to draw a line down our equal sign just like we've been doing in class, and now we're going to start solving. I want to get x by itself. To get rid of x, I need to get rid of this. To solve for x, I need to get rid of this plus 4. So I'm going to subtract 4. So now I have canceled my 4's on the left-hand side, and now I have 3x. I've brought my inequality symbol down, greater than or equal to, and then negative 8 minus 4 is negative 12. Now I have multiplication. I have 3 times x, and so to cancel multiplication, we divide both sides by 3. And I'm bringing everything straight down. My x comes down, my inequality symbol comes straight down, and then negative 12 divided by 3 is negative 4. For you to get credit for solving an inequality, you must give us this entire answer. You have to give us x is greater than or equal to negative 4. Okay, so here's example 2. Negative 2x plus 1 is greater than 7. So this would be our greater than symbol. So again, we are trying to get x by itself. We're just solving like this is an equation. So I'm going to start by canceling plus 1 first. So I'm going to subtract 1 from both sides. And then I'm bringing down everything I haven't used. I have the negative 2x, my inequality symbol, and then 7 minus 1 is 6. Again, I have negative 2 times x, so to cancel multiplication, we're going to divide both sides by negative 2. This time I'm putting this in red because this is our one extra rule with inequalities. When you multiply or divide, in this case we're dividing, by a negative number, the 2 is negative, it doesn't matter about anything else up above, the 2 is negative, we need to flip our inequality symbol. So my greater than symbol now becomes a less than symbol. So my 2's canceled, I have x, 6 divided by negative 2 is negative 3, and I flip my inequality symbol. Okay, so let's look at a couple other examples. Okay, so x minus 10, and the whole thing this time is divided by 5, and this is our less than symbol and 7. So I'm going to cancel the 5 first because we can't have this big fraction, so I'm going to multiply both sides by 5. Right, so when I multiply both sides by 5, these just cancel. That's just a formality. And then I am left with just the top of the fraction, the x minus 7. I bring down my inequality symbol, and then 7 times 5 is not 25. 7 times 5 is 35. We'll fix that. That's 35. Whew. That means everything else is wrong now, too. See, I even make mistakes on videos. So to finish solving, we're going to add 10 to both sides, and I'm going to have to fix my final answer. So x should be less than, and that should now be, just scribble that right out. That should now be 45. And again, you need to have your whole answer for it to count an inequality. We have to have the x, the less than symbol, and the 45. Okay, here's another example. 2x minus 1, the whole thing is divided by negative 3, less than or equal to negative 5. So we're first, again, we can't have this big fraction. We're going to get rid of the negative 3 first. So I'm going to multiply both sides by negative 3 because it's being divided. And again, this time I'm going to put this in red because this is part of our new rule. When we multiply or divide by a negative number, and this time we are multiplying both sides by a negative number, we need to flip our inequality symbol. So first, our 3's cancel. That was our formality. I'm left with the top, 2x minus 1. Negative 5 times negative 3 is 15, and then I flipped my less than symbol to a greater than symbol. And now we can finish solving. I need to get rid of the minus 1 by adding 1. That now gives me 16. And then I'm going to get rid of the 2 by dividing both sides by 2, and I get x is greater than or equal to 8. All right, let's look at a couple more examples. All right, negative 5x plus 1 plus 3x is greater than negative 7. So the problem with this is we can't start solving yet because I have like terms. So I'm going to have to get my like terms together. Negative 5x plus 3x will give me, oops, put that in the wrong place, negative 2x. And then I still have the plus 1, and I still have the greater than negative 7. And now we're going to start solving. I'm going to subtract 1. That gives me negative 8. And then I'm going to divide both sides by negative 2. Again, I put that in red because when I'm dividing by a negative, I need to flip my inequality symbol. So negative 8 divided by negative 2 gives me 4, and my greater than symbol now becomes a less than symbol. Okay, here's our last example. And I want to give you this example because x is on the right-hand side instead of the left-hand side. And this feels a little uncomfortable for some of you, but with an inequality, you just need to leave it here. You need to leave it on this side. Don't try to move and flip x over to the other side. So we're still solving. Trying to get x by itself, I need to get rid of minus 7 by adding 7. So 4 plus 7 is 11. And now I have that negative 2x, negative 2 times x. So that means I'm going to divide both sides by negative 2. I'm dividing by negative, so that means I have to flip my inequality symbol. So this 11 divided by negative 2 gives me negative 5.5. I'm leaving that on this side because that's where all my numbers are. See, there's all numbers on this side. There's no x's. My x is on this side, it stays on this side, and then I flip my inequality. This is a perfectly fine answer, and we would prefer that you leave your answer that way. Okay, so I hope you learned something new, and I hope that you can now complete some work in class with a little bit of help. And behave for the substitute. Thank you.